And now we're looking at risk measures. Risk measures are also risk assessment, but remember, risk measures are something where we say, hey, right now, really right now, what is my exposure to certain option drivers? One thing that I didn't mention, and I should say it here. So what we have done here with the graphs, the cool thing about this graph stuff with the option graphs, this doesn't need a model, right? So you don't need tools for that. You just need to know what options do I have and how much did I pay for them, right? That's the only thing you need to know. When we go to risk measures, you need a machinery. You need option models that calculate for you the exposure, right? So we have this graph here, right? So this is the option. We know, or let's say the option value or the change in the option value. And you see here are the drivers. The drivers are underlying volatility, carry cost, time is a driver. All these things are drivers of the options. And I want to know if one of those drivers changes, how does it affect me? I want to actually know what exposures do I have in my option strategy. So it's like you think you bought an option strategy. This is in a bag. You don't know exactly what's in there. And like at the airport, if you put it through the scanner and somebody can watch inside, that's what the risk measures are doing. Now option prices depend on many things, right? But the most important option drivers, they are the absolute most important option driver is the underlying. The price of the underlying is the absolute most important option driver. That's why we have two risk measures that explain to me what's happening here. Then the next important option driver is volatility. And how much a change in volatility would affect my option value. That's what we call vega, right? And then, of course, interest rates, rho, phi, I think we talked about, not sure which one we talked about. The one is change in, say, dividends, and the one is change in interest rates. Usually in this course, we don't talk too much about those. But then theta, that's the passage of time. It's not really a risk measure in that sense because you cannot influence it. Time is going by, so you either gain or lose, but that's what people call theta or time decay, because an option is usually losing value when time goes by. As always, best thing is to watch, of course, our videos and then make an example. And this is the example here. So what I have done, let's say I bought a straddle. And we know what a straddle is. A straddle is a call and a put with the same strike. So I buy a call with a given strike and I buy the put with the same strike. Let's assume we bought these options at the volatility of 20%. And now I put that stuff in my machine. My machine gives a value to the call and the value of the put. Hopefully that's what I have paid for, maybe a little bit less, whatever. And then the machine, and this you cannot do this without the machine, you need an option pricing model for that. I calculate the risk measures, delta, gamma, vega, theta. And here are the risk measures. Right? And okay, if we say, let's put this in some questions, I say if these options were priced at the volatility of 19%. So we said we bought them at 20. So you could say you could phrase in a different way. You can say, what would happen with the value of my option if the volatility, the implied volatility, so kind of the fear of the people, changes from 20 to 19%. And nothing else changes in my option world, right? By how much would the value of the straddle change. Or you can say, let's assume, that's another question, nothing happens at all, 1 month goes by, what would happen to the value of my straddle? Good. So let's briefly do that together. The most, well, not the most important thing, but let's first look at these options, at these two options. So if we just try to analyze, it is usually good if you have a price of a call and a put to just analyze it a little bit. So you see the call and the put, we said it's a straddle, so they have the same strike, same underlying, same expiry. The call is a little bit more expensive than the put. So that means the call is a bit in the money and the put is a bit out of the money. Then you have delta, right? What does delta tell you? Delta tells you how much of the underlying you have in your options. So the call has a delta of 57, so 57%. That means right now the call has the same exposure to the underlying as if I had 0.57 underlyings in my hands. The put, on the other hand, a put is a bearish position. I'm long a put. That behaves like a short position in the underlying. Then I have gamma. Gamma tells me how much delta will change if spot is changing, and gamma is 0.3 of both options. By the way, this is not a coincidence that it's the same for both options. This is just because put-call parity. Remember what put-call parity is saying? We buy a call, we sell a put. What do we have? We have the underlying or forward in our hands. The forward has no curvature, has no gamma, so therefore the gamma of the call has to equal the gamma of the put. Not so important, but you will always see if they have the same strike, same underlying, same expiry, the gamma, and also the vega of these options is the same. What is vega? Vega, and I called it here also tau because in ancient times UBS called vega tau, and sometimes in risk, in the risk runs you might even see that. So this means the call, which has now a value of 6.237, would increase by 28 cents if the volatility went up by 1 vol point from 20 to 21, right? That's what theta is saying. And then the time decay. Now the time decay is a little bit special because, as we said, these risk measures tell you what's happening to the option if if something changes on a small scale. So for example here, if time would go by, just if a day goes by or a year or 2 days go by or 5 days goes by or a month goes by, like said here. But I have to express it somehow. So here I expressed the decay as dollars per year. So this is just the rate at which it's changing. I'm not saying I can use theta to really find out what is the value of the option in 1 year. I'm just saying that is telling me, right, what is happening if I use as a language dollars per year. But I could also, and what is probably what you see more on a trading screen, might be cents per day. So that means I would have to divide this number by how many days I have in the year. The reason I have not done it, because I would have to think about, do I want to think in trading days or calendar days? And that's why I have it dollars per year. But let's now go to these questions. First thing, very, very important. Risk measures are additive, right? As a mathematical concept, they are derivatives, the derivation with respect to whatever, spot or so, and so they are additive. What do I mean by additive? If you think about the option value, You automatically know it's additive, right? What do I pay for the whole straddle? Of course, I pay the call, I pay the put. So for the straddle, I pay something like 11, whatever that is, 25 or 15 or whatever it is. And in the same way, I can add delta. Did it here. Risk measures are additive. So you see, I mean, the option value is the value of the call and the put. The delta of the whole structure is the delta of the call plus the delta of the put. 57% plus minus 43% is 14%. 3% plus 3% is 6%. 0.28 plus 0.28 is 0.56, etc., etc. So very important. And that's why the cool thing, right? You can just put everything together and now you have the exposure that your whole strategy is giving to you. And you can already see it. I mean, wow, we have very little exposure to the underlying. Delta is very small, but you have big numbers wherever we talk about optionality. So gamma, vega. And then, of course, because you have a big optionality, you bought the call and you bought the put, you have also quite a high theta, right? That theta is about, well, it's actually $11.19 per year. But let's do it, let's say, per day or per month, right? So what would that be? It's roughly 12, not exactly 12, but 12-ish, right? 11.19. We have 12 months in a year. So that means this option would lose in a month about $1. It's worth 11.25 the straddle, and every month it seems it loses about $1. Or if you then calculate this per day, right? $1 per month, and would have to divide it by 30. That's about 3 cents per day. That's the decay of this whole position. Now it's very easy. With that, it's very, very easy to calculate actually to go through the questions. We said what's happening if volatility goes from 20 to 19. Well, we know that here the sensitivity to volatility is 56.56, so $0.56. So for every volatility point I gain, my option will gain 56 cents in value. But if I say volatility goes down by 1 vol point, so this option would lose 56 cents. And the new value would therefore be 11.25 minus 0.56, which is 10.69. The other one we actually already gave the solution in a certain way. We have a theta of about 12. That means if 1 month passes, the option loses about $1. And it goes from 11.25 to something like 10.25. Of course, if you calculate this more precisely, because it was not exactly 12, you see that over a month it loses about 93 cents. So that's how option measures are used. So quite a, how should I say it? Quite a strong concept, because our human brain can only work with one exposure at a time. So to break down the total complicated exposure to the option drivers, to the drivers of the option, we now split it in how much does it change if the underlying changes, etc. Good. We, of course, could, if we wanted so, but our time is running out a little bit. If we wanted, we could go back to that screen that Vincent created last time to see the options or the delta and the gamma of the S&P 500 options, right? And just if you do that, what you can see is that once we are at the money, right? These options are at the money. At the money, the delta of an option is close to 50%. the delta of a call is always positive if I'm long the call. The delta of a put, if I'm long the put, is always negative because put is a bearish position in the underlying. Right? So roughly 0.5. At the money, it's 0.5. The more I'm in the money, the more the delta moves to 1 for calls and -1 for puts. The more I move in the out of money direction, the lower the delta, right? That's the behavior of the delta. Cool. So that was it for risk measures.